All right, so we're going to start chapter 2, and that is over descriptive statistics. So you can go ahead and title this. Now, this chapter is going to deal with a lot of bar charts, pictograms, pie charts, as you can see on the left. So that's why I want you to finish all of those Khan Academy assignments by Friday, just so that you're familiar with looking at a graph. From there, I do want you to try these skills checks. So the first one says Marilyn, I'm guessing that's how you say her name, wants to find out information about the numbers of men, women, boys, and girls using a library. Design a suitable data collection sheet to collect this information. So go ahead and pause and do that in your spiral. Number 2, the data show the number of different colored sweets in a packet. The colors blue, green, red, orange, and yellow, and then the frequency that they occur. So you need to do A, draw a pictogram to represent these data, B, draw a bar chart to represent these data, and C, draw a pie chart to represent these data. I feel like it should be this data, but whatever. Number 3, also do this. So on your graph paper in your spiral, draw a set of axes such that 1 centimeter represents 2 units on the x-axis and 1 centimeter represents 10 units on the y-axis. If you do not have a ruler at home, I will allow you to do this the next 5-ish minutes at the beginning of class, and you can use one of the rulers in the basket. So now we're just going to keep going. So your next section is introducing you to the idea of population. That way we can grab samples from these populations. So here they talk about your census survey. Okay. And for example, in the United Kingdom, there is a census every 10 years. So these are called population pyramids, what's in red and orange. And it's saying that those population pyramids are based on information collected in the 2001 census. They show the distribution of age ranges in the Tower Hamlets, London, and that place that I'm not going to attempt to say. So looking at these two, the Tower Hamlets and that other one, it's kind of interesting because they both look like they start off about the same at 0 to 4, and then the census on the right seems to grow and then shrink suddenly at 24, whereas the tower over here seems to kind of keep growing, with the largest amount being at that 25 to 29 age group. And largest over here seems to happen kind of later on, 35 to 39, and then 50 to 54, and then that 70 to, or 65 to 74 group. So this is just saying, on one side, you have your male population, the other side is your women's population. So if I were to compare it to every single group, only a small percentage of my population are over 90, and they appear to be all females. Whereas this is the majority, or how much of the population that age group takes, and it looks like the men and women are fairly equal, maybe a little bit more women. And then over here, things are a little bit more symmetrical across the board, but skewed, I would say, to where they have more men as opposed to women. So that's kind of interesting. So basically, you've got to find a way to convey whatever data that you're measuring in the best way possible. So if you're comparing overall population and you've got 2 categories within that, that's why we did men and women, and they can show you the comparison between those at each level and by the 2 graphs overall. So as you're going through this unit, we're going to introduce a lot of different ways to collect data and measure it, and you've got to start thinking about how your project is going to come together. So to do that, we're going to go ahead and look down here at classification of data. So this is the next thing I need you to actually write down. So, okay. So there are two main types of data, qualitative and quantitative. Qualitative data are data that are not given numerically. For example, your favorite color. Quantitative data is numerical. So if I were doing notes, this is how I would start mine, and then I would have wrote qualitative, because there are two kinds, and quantitative. And then I would probably define this a little bit more. So I would say like not given numerically. And then I would just abbreviate favorite color, something that's not like a number. And then quantitative, that is given numerically. And then there are two kinds. You've got discrete and continuous. And then I would go back and fill in what each of those are. So this is what you can count. So a long time ago when you did domain and range, discrete data was whenever you did everything in lists. Continuous was when you wrote those inequalities, because discrete is something you can't cut in half. So if we were to count all the desks in a room, that's discrete because I can easily see that there's 0, 1, 20, however many desks there are in that room, I can easily count them. If we had half of a desk, that's broken. No one wants that. So if it's not something that makes sense, if you were to cut it in half, then that is discrete. Continuous. Oh, where'd it go? Okay, so that's it filled out a little bit more. And then for desks, you can also do like number of suites, people who prefer tea to coffee, and number of pairs of shoes that a person owns. So again, anything that can be counted. Okay, so all of those were example of data that can be counted, but other data that is discrete that would also be examples like shoe sizes, hat sizes, dress sizes. So I'm not measuring them, I'm not counting it, but that size is assigned a number. So that would be the specific kind, not just counting. Okay, so just wrapping this up, we have discrete and continuous, and if it was me, I would have actually stopped and looked at examples of discrete or continuous if I was in class for a college course. But these I already know, so I'm going ahead and fill these out for you if this helps you. So continuous, that was something that's measured, and it can be taken within a range of measurements. So like temperature would be one of them, because we don't go from like 1 degree to 2 degrees, something like that. It slowly rises. You can have 2.5, 372.8, 263 point whatever. You get it. So temperature, anything that has decimals, so like weight, if you were to measure yourself on a scale, that's continuous. Those things fluctuate. So any type of measured amount. On your other hand, you have discrete, so that's number of whatever it is you're counting, whether that's CDs or desks or books or anything along that line, that would be discrete, something that you can't put in half. Now, if we're not counting numbers of something, we already had the examples where they can take on a specific value. So that would be clothing sizes that they talked about over here. Okay, so this one has a whole lot of vocabulary that we're adding on to here. So we've got population, and remember, these are terms that you're going to need to use in your IA project. So population, that's your whole group that you gather data from. So if you're wanting to measure all the students at Chavez, your whole group is all the population of teachers and students and staff members that work at that school, and then you may be measuring something in Chavez. If you're wanting to compare something from state to state, like Texas versus Louisiana, your population would be all of the people who live in Texas and all of the people who live in Louisiana. But most of the time when we are conducting a survey, it's impossible to actually talk to every single one of those people within that population. So because of that, we take a sample. So that's just a small group from that population. And those are the people who are going to be taking the surveys and, running tests. That way they can be an example of what the rest of the population does. So to make sure that that's fair, you have to conduct a random sample. So if I were to ask every fourth person, that walked through the door, that would be considered random because I'm not picking out people who say all have third period with Coach Giles, or everyone who has brown hair, or all the, you get what I'm saying. It has to be random. So their definition is where each element has the same chance of being included. Of course, I can't type whenever people are watching. Of being included. There we somewhat almost go. Okay, so then you have bias sample, one that is not random. So if you're asking a question that's not, or a question that sounds leading, you could actually ruin your whole survey because you didn't ask a generic question. Your question was biased, that made people pick something over another. So the wording of your surveys will be important, and we'll go into that a little bit later. And then the last information that you need to get from all of these definitions is representative. Okay, and then you have representative, so the sample must be random to accurately reflect a population. So again, your sample, if it's all biased, everything you talk about in your paper will not be able to do anything because you can't prove anything with a biased sample. So all of these vocabulary words are ones that you really need to know because you do most likely need to speak about them in your project if you are doing correlation or anything where you're gathering data from some type of sample. Okay, so that's how my notes would have looked, and then I would have made flashcards, and you should make flashcards from every word that's highlighted, and then I would definitely suggest including examples. So if there's something you need to look up, feel free to look up things on Google to make sure you understand these words, but these are ones that you're going to really need to. Okay, so two little examples here. This person wants to find out if there's a connection between eating breakfast and grades, right? You always hear that you're supposed to eat a good meal before you have an exam or whatever. But because there are too many students at the school to ask each person, she picks a sample. So we need to make sure that she does this randomly. So to do that, she can use her graphing calculator to generate random numbers, and students who have those numbers on the school register. So something like that is random because you're not just picking one type. Over here, if they're conducting a survey to find out how much money women who live in London spend on fashion, she's only interviewing people out of one store. So this is not random because not all of the women that live in London shop at that particular store. So she's already being exclusive and swaying her data because she's only getting them from one source, which is not something that the majority of the population go to. So go ahead and stop and do exercise 2A. Okay, once you have completed all of these, move forward to number 2. Okay, and let me know if you have any other questions, but that's it for this first video.